Assalamu alaikum. I am Mohammad Jahangir Alam, lecturer in physics, and I am from Milestone College. I welcome you all in my online class. First of all, thanks to Almighty that He has given me the ability to take this class. Dear student, here I also hope all of you are well with your families and passing your good moments, carrying on your regular studies by the mercy of Almighty. Right? Dear students, today we are going to perform an experiment, okay, or practical class, and our experiment is determination of a specific resistance of the material of a wire using meter bridge. Right? Here first we have to understand what is meter bridge. It's an instrument by which we can determine the value of a unknown resistance using Wheatstone bridge principle. Right? So here I would like to introduce a meter bridge. Right, dear students, this is our meter bridge. Actually, on a wooden board, here is a meter scale, and beside it there is a wire of 1 meter length or 100 centimeter. Here are metal strip. There are two gaps. One is known as left gap and another is right gap. Actually, this instrument act on the basis of the principle of Wheatstone bridge. Dear student, already we have observed what is meter bridge. So using meter bridge, we have to determine the specific resistance of the material of a wire using meter bridge. And for this experiment theory, first we have to know what is a specific resistance. The definition of a specific resistance, then the resistance of a wire having unit length and unit area of cross section is called a specific resistance of the material of the wire. If the length of the wire is L, if the length of the wire is denoted by L, area of cross section is denoted by A, and resistance of the wire is P, then the specific resistance can be expressed as rho is equal to PA divided by L. P is the resistance of the wire, is the area of cross section, and L is the length. If the radius of the cross section of the wire is R, then A can be replaced by pi R square. So a specific resistance can be measured by P pi R square divided by L. Right? Again, if the resistance of unit length of the wire in meter bridge is sigma, sigma is the resistance of unit length of the wire used in meter bridge, then the resistance of the left portion of the wire is L sigma, since sigma is the resistance of the unit length. So resistance of L length is L sigma, and that of the right portion of the wire is 100 minus L into sigma, since the total length of the wire is 100. Now according to the Wheatstone bridge principle, P by Q, here P is the unknown resistance and Q is the known resistance, L sigma divided by 100 minus L into sigma. Okay. If we cancel out sigma from the both part, then it will 100 minus 100 divided by 100 minus L. Right? When P is in the left gap, for better result, we will place the unknown resistance first time in left gap and then in the right gap, and then we will get the average value. So when the P is in the left gap, then P can be calculated by this formula, P is equal to L divided by 100 minus L into Q, and when P is in the right gap, then P can be calculated as P is equal to 100 minus L divided by L into Q. Right? I hope you got it. So now it is time to go to the experimental table or meter bridge. Right? So let's move to the meter bridge and get we have to collect the data from the meter bridge. Okay. Okay, let's see the required apparatus for the experiment. First, we need the meter bridge. We need a galvanometer, a resistance box from which we will get the known resistance, a battery case, and a cell, one jockey, and connecting wires. We also need a micrometer or screw gauge to measure the diameter or radius of the wire of which a specific resistance is to be determined. Dear student, now we will see the connection for the experiment, left end of the meter bridge, which is denoted by A. The positive end of the cell is connected with the A point. Then we will connect the wire of which specific resistance is to be determined in the left gap for the first step of the experiment. Here B, with the connecting point of B, we will connect the one end of the galvanometer, and other end of the galvanometer will be connected with the jockey. In the right gap, we connect a resistance box from which we can set a resistance of known value, and at the C point, negative end of the cell is connected. This is the connection for the experiment. Now we are going to collect the data for the experiment. That is, first we are going to determine the resistance of the wire using meter bridge, and the next step we will determine the radius of the wire using screw gauge, right. We will determine the resistance of the wire in two steps. First step, we will connect the resistance in the left gap, and in the second step we will connect the resistance in the right gap, and known resistance will replace to the left gap, right. Let's collect our data. Dear students, after the connection, first we will verify whether connection is right or wrong. If we connect the jockey at the left gap, then the deflection in the galvanometer will be in right side, right. You observe that. But when the jockey is connected in the right side of the meter bridge, then the deflection will be in the opposite direction, that is in the left side. Okay, so we can realize that the connection is correct. Now we are going to collect our data and fill up this table. Okay, in the table you can see that the position of the unknown resistance, that is the resistance of the wire, which is denoted by P. When the resistance is placed in the left gap, already we have connect in the left gap, we will collect three datas, and when we resistance placed in the right gap and known resistance will replace to the left gap, then we will connect another three datas, and after the calculation we will get the average value of P. Okay. Okay. Dear student, first we have placed the unknown resistance in the left gap and known resistance in the right gap. If we open this key, we will get 1 ohm resistance. Here 1 ohm is marked here. Now we are going to get the value of L for these settings. From the left side, if we move the jockey over the wire, we will get the null point at, you can see the deflection in the galvanometer is 0, and here the reading on the meter scale is 43 centimeter, right. This is the value of L for the combination. So we are going to complete the table. For the known resistance 1 ohm, the value of L is 43. Okay. Now we are going to get the second reading, then we can change the known value by 2 ohm. When in the resistance box is 2 ohm, then we will get the another reading of L. Here you can see the deflection is 0. So in this situation or in this state, the readings in the meter scale is 34 centimeter, right. Okay. So when the known resistance is 2 ohm, then the value of L is 34 centimeter, right. Now if we open these two key, then the total resistance in the box will be 1 plus 2, 3 ohm, and in these settings the value of L will be here. I think this is the null point, and the reading in the meter scale is 26 centimeter. Okay. So the known resistance is 3 ohm and length of the L is 26 centimeter. This is the first step. These are the reading for the first step, that is when the unknown resistance is in the left gap and known resistance is right gap. Now we are going to replace these two resistance. We will set the known resistance in the left gap and unknown resistance in the right gap. Okay. We have already replaced the resistances, that is known resistance in the left gap and unknown resistance in the right gap. So we are going to repeat this process. In the first case, we have to remove a key from the known resistance, and here the value of the known resistance in 1 ohm, and the deflection we get for the 1 ohm is, here the deflection is 0. So the value of L is 55 centimeter, right? So for the first observation, value of known resistance is 1 ohm and value of L is 55 centimeter, right? Now we are going to repeat this process for 2 ohm in the left gap. Okay. And in this case we are going to we got deflection 0 at 65 centimeter, right? So when the known resistance is 2 ohm, we got the value of L is 65 centimeter. And finally for the 3 ohm in known resistance box, we got equilibrium at exactly 72 centimeter, right? So for 3 ohm the value of length is 72 centimeter. We will complete this 2 column after. Okay, dear student, using this equation and using this value, we get the value of P, that is when the unknown resistance was left gap, the respective values for the 1 ohm is 0.754 and 1.030 and 1.098, and when the unknown resistance in the right gap, then the values are 0.818, 1.077, 1.166, and the average value of this value of P is 0.99 ohm. Okay. Now we are going to complete this table, that is now we have to measure the length of the experimental wire and radius of the wire. Okay. The student, the wire is very thin, so we have to be careful to measure the length and radius of the wire. Okay. First we are going to measure the length. Here the wire is placed at the 0 mark of the meter scale and press it tightly. Then the other end of the wire, the other end of the wire reaches to 23.7 centimeter. Okay. So this is the length of the wire, right? 23.7 centimeter. Value of L is equal to 23.7 centimeter. Okay. Now we are going to measure the radius of the wire. Dear student, first you have to observe that there are two scales. One is linear scale and another is circular scale. You can see that the 0 mark of the circular scale is coincide with this mark of the screw gauge. Okay. And there is no gap between the two jaws. When we open this scale, you can see the circular scale is giving the readings. We have to measure the radius of the wire, since this will be a very acute measurement, so we will measure the radius at different places of the wire. First, if we measure the radius of the wire in the left end of the wire, after placing the wire between the two jaws, you will tight the jaws, and when the two jaws touches the wire, that is, there is no gap, and in this case the reading in the scale or screw gauge, linear scale reading is 0, linear scale reading is 0 and circular scale reading is 25. Okay. So, we are going to add the value, linear scale reading is 0 and circular scale reading is 25. Now, we are going to get the second value of the diameter. We are going to get the result at the midpoint, that is from the midpoint of the wire. It will be approximately at the midpoint, and in this case the readings is almost equal. Here the circular linear scale reading is 0 and circular scale reading is 25. Okay. So, 0, 25. Now, we are going to get the last reading for the radius. We will place the right end of the wire between the two jaws. For the third reading, the right end of the wire is placed between the two jaws, and in this case the reading is, circular scale reading is 27, linear scale reading is 0 and circular scale reading is 25, 26, 27. Okay. Now, we are going to complete the other column. Here the least count of the micrometer or screw gauge is 0.01 millimeter, which is indicated in the micrometer. So, value of K, that is least count, is 0.01 millimeter. The unit is in millimeter. Okay. Here F mean fraction reading. Fraction reading we will get by the product of K and C. Here K is 0.01 and C is the reading of circular scale. So, the first reading will be 0.25, second reading is 0.25 and third reading is 0.27. Okay. This is the total reading for the diameter. Diameter will be L plus F. L means length reading of the linear scale. In the all cases the reading of the linear scale was 0. So, the summation of L and F will be 0.25, 0.25, 0.27, and there is no instrumental error in our instrument. So, instrumental error is 0. Okay. So, actual diameter of the wire was 0.25, 0.25, 0.27. Average, now if we add this 3 value and divide by 3, then we will get almost 0.26, right. So, radius of the wire will be, if we divide the diameter by 2, then it will be 0.1. If we convert the value into meter unit, then it will be 0.00013 meter. Okay. Already we have convert the value of length, that is length of the wire is in meter unit, 0.237 meter. Now we are going to calculate the final calculation. Here the value of P, which is obtained from the first table, 0.99 ohm multiplied by pi, 3.14 multiplied by r radius, which is will get from the value 0.00013 square divided by L decimal 0.237. Okay, and after the calculation we will get 2.22 into 10 to the power minus 7 and unit will be ohm meter, right. This is the specific resistance of the wire, right. Dear student, I hope you got everything for the experiment, but if you have any confusion you can contact your subject teacher. You can come to our lab, we will try to solve it. Okay, so thank you very much being with me in my class. May Allah bless all of you. Thank you. Assalamu alaikum.